What's up everybody, and welcome to a new video. And in this video we're going to go over my notes for comprehensions in Python. Namely, there are three different types. There are list comprehensions, dictionary comprehensions and set comprehensions. So let's start here with the list comprehensions. Namely, a typical workflow that you often encounter when programming is to populate a list within a for loop. So for example, here I've prepared this for loop. So here we initiate this list variable to an empty list. Then here we create this for loop where we loop over the range from 1 to 11. And then here in each iteration of the for loop, we append an x squared to our list here. So then if I print out here the list, then we get here this list with these squares, and you can do the same thing with a list comprehension. The only difference is that list comprehensions make the code more succinct. So the general structure of a list comprehension is as follows. Namely, a list comprehension consists of brackets containing an expression followed by a for clause, and then 0 or more for or if clauses. So let's now unpack that step by step, and let's start with a basic list comprehension. So we're only looking at this part here of the definition, namely brackets containing an expression followed by a for clause. Okay, so now let's do here the same thing. So then to create a list comprehension, we start here with the brackets. And then I personally like to start here with the for clause, so just like a regular for loop. So therefore I leave then here a space. And then here we say for x in range 1 to 11. And then here we can insert our expression. So in our case, this would be then x squared. So now if I run this, then you can see that we get here the same list as with this for loop. So this is how a basic list comprehension works. Then next, let's look at a list comprehension with an if clause. So to show that, let's create here another simple list comprehension. So let's again say brackets, and then here for x in range 10, let's simply have here an x. So if we run this, then we get here this list going from 0 to 9. And now let's say that we only want to have here even numbers. So therefore we can use the if clause. And as you can see here in this definition, the if clause comes after this for clause. So therefore let's simply now copy this cell, and then here let's insert our if clause. So here then we to get the even numbers, we say if x and then the modulo operator. So if we divide x by 2 and then the remainder is equal to 0, then we have an even number. So then if I now run this, then we only get here those even numbers. And as you also can see here in this definition, you can also have multiple if clauses. So for example, let's add another one. So then here, let's say that we actually only want to have the numbers that are bigger than 3. So we only want to have here this 4, 6, and 8. So therefore then we can insert here another if statement. So if x is bigger than 3, and now if I run this, then we only get here the numbers 4, 6, and 8. And here, just as a side note, here you could also use the Boolean operator and instead of the second if statement. So if I run it like this, then we also get here the numbers 4, 6, and 8. So this is how a list comprehension with an if clause works. Then next, let's look at a list comprehension with a for clause. So to demonstrate that, I've prepared here this variable. So let me copy and paste that. So here we have a nested list. And let's say our goal is to try to flatten this nested list. So the output should look like this, where we have a list simply containing the numbers 1, 2, 3, 4, 5, 6. So to do that, let's create here a list comprehension. So then let's first here loop over those sublists here. So let's say here for sublist in nested list. And now we can use here this second for clause. Namely, in this case, then let's simply here loop over those sublists then. So here we're going to say then for element in sublist. And then what do we want to have? We want to have here simply this element. So let's here put in the element. And now if I run this, then we get here our flattened list where we have 1, 2, 3, 4, 5, 6. And this might look somewhat complicated. However, it's actually easy, because if you would do the same thing with a regular for loop, then the code would look like this, where we also say here for sublist in nested list and then for element in sublist. So then if I run this here, then we also get the same result. So as you can see, the order of those for loops here in the list comprehension is actually the same order as you would have with regular for loops. Okay, so this is then a list comprehension with a for clause. Then the next note is about nested list comprehensions. And this has actually nothing to do with this definition here. However, I wanted to show that it is also possible to create nested list comprehensions. And here we're going to look at two examples. So the first one is going to be a list with sublists that subsequently increase in length. So what I mean by that is the following. So here I've prepared such an example list. So here we have this overall list, which contains these sublists, and those sublists here subsequently increase in length. So here we have an empty list. Here there's one element, there are two elements, and then here there are three. Okay, so now let's create such a list with a list comprehension. So therefore, let's simply here start with the brackets. And then let's start here with this outer list. So we're going to say for I in range 10, for example. So let's create 10 sublists. And then here, let's simply start with an empty list. So now if I run it like this, then we get here this overall list with those 10 sublists. So now let's write the code in such a way that those sublists here actually increase in length with each iteration. So let's also make this here a list comprehension. So this is then our nested list comprehension. So here then, to make sure that those sublists subsequently increase in length, therefore, then we can simply use here this I, which is in the first iteration 0, then 1 and 2 and so on. So here then we're simply going to say for j in range I. And then what do we want to have? We simply want to have those numbers here. So here then we're simply going to say j. And now if I run this, then you can see that we get here this overall list that contains these sublists, which subsequently increase in length. So that is the first example for a nested list that I wanted to show. Then the next example is about transposing a matrix. So to show that, I've prepared here this example matrix. So this is our example matrix, which has 2 rows, and each row then has 3 elements. And then this here is what that matrix looks like transposed. So as you can see, the columns of this matrix here become the rows of the transpose. So the second column here is then the second row, and the third column is this third row. So then what we want to do to create this transposed matrix is the following. Namely, for this first sublist here, we want to loop over all our rows in the matrix and then pick here this first element. Then for the second row, we want to again loop over all the rows of the matrix, but this time we're going to pick the second element. And then for the third row here, we again loop over all our rows and then pick here this third element. So therefore then we first need to determine how many elements there are in our matrix, because if there would be 4 elements, then we would need to loop a 4th time over our matrix here. So therefore then we simply say n elements, and this should be equal to the length of one of our rows in our matrix. So let's simply pick here the first row. So now we can use this n elements to determine how often we want to loop over our matrix. So therefore then let's create here the list comprehension, and then we're going to say for I in range n elements. And now what we want to do in each iteration is to create those sublists here. So here we can then going to create our nested list comprehension. And as I said, what we want to do here for each row is to loop over all the rows in the matrix. So we're going to say here for row in matrix. And then what we want to have is for the first iteration of this for loop, we want to only have the first elements. For the second iteration, we want to have the second elements and so on. And therefore we can use this I here. So therefore then here we simply say row brackets I. So now if I run this, then we get here this transposed matrix. And now just to make it a little bit more better formatted, let's use here the pretty print function. So we're going to say from pretty print import pretty print, and then let's put this list comprehension here into a variable called matrix transpose. And then let's pretty print that transposed matrix. So we're going to say pretty print matrix transpose. and then we're going to set the width equal to 20. So now if I run this, then you can see that we get this better formatted matrix, and it looks exactly the same like this transposed matrix that we have seen here. Okay, so those are the two examples that I wanted to show with respect to nested list comprehensions. So now let's go over the side note here, which is about list comprehensions with an if-else statement. So to show that, let me here again create a simple list comprehension. So we're going to say for x in range 10, and then here we simply want to have x. So now if I run this, then we get this list going from 0 to 9. And now let's say that for the even numbers, we actually do want to have the x. However, for the uneven numbers, we want to have underscores. So therefore, we can use here this if-else statement. So therefore, let's simply copy and paste the cell. And now this if-else statement, however, is not put after the for loop, but it is put after the expression. And I will explain why in a moment. So now let's just here say then that we want to have the x only for the even numbers. So here we're going to say x, if x, and then modulo operator 2. So if x divided by 2, and then the remainder of that should be equal to 0. So that's for the even numbers. Else, what we want to have is simply an underscore. So now if I run this, then you can see that for the uneven numbers, we have now here this underscore. So now let me just explain why this if-else statement here is actually after the expression and not after the for loop. And that's because this part is actually a so-called conditional expression. So it's not actually part of list comprehensions. So that's why it's not listed after the for loop, where if statements are normally put. Okay, so this is the side note. And with that, now we've covered how list comprehensions are defined and how you can use them. So now let's go over the side notes here. And the first one states that in contrast to a for loop, there's actually no variable created with a list comprehension. So to show that, I've prepared here this simple for loop where we create here this list. So if I run this, then we get this list here from 0 to 9. And then if I print out here the y, then you can see that it is 9. And now let's do the same thing with a list comprehension. So here, let's say list equals list comprehension, where we then say for z in range 10, and then here we want to have the z, and then let's also print out that list. So here we get the same list. However, now if I try to print out the z, then you can see that we get here a name error because name z is not defined. So as you can see, there's actually no variable created with list comprehensions. And then the next side note states that a comprehension is usually faster than a for loop. And to show that, I've prepared here this for loop where we have 1,000,000 iterations. And now to time it, I'm going to use here this magic command, time it. So this simply measures how long this takes on average. So here, as you can see, it took on average 251 milliseconds. So now let's do the same thing with a list comprehension. So here is the list comprehension. And now if I run this, then you can see that this takes 214 milliseconds. So as you can see, in this case here, the list comprehension is faster than the for loop. Okay, so with that now we've covered here these side notes. And with that then we've covered all my notes with respect to list comprehensions. So now let's see what dictionary comprehensions look like. And therefore let's look at a simple example. So the dictionary comprehension that we're trying to create is the following, where we have here this dictionary where the key is simply a number and then the value is the square of the number. So we have here the square of 1 is 1, the square of 2 is 4, the square of 3 is 9, and so on. So now let's create this here with a dictionary comprehension. So therefore we're going to use braces, and then here we're going to say for x in range 1 to 6, and then here what we want to have for the key, we simply want to use x, and then for the value we want to have x squared. So now if I run this, then you can see that we get here this exact same dictionary. So this is how you can create a dictionary comprehension. And then here I basically just have this one note, namely the if clause, for clause, nested dictionary comprehension, and if else statement, they work exactly in the same way as with list comprehensions. So I'm not going to show them here. So therefore then we've already covered all my notes with respect to dictionary comprehensions. So now let's see what set comprehensions look like. And therefore, let's again look at a simple example. So therefore, I've prepared here this code snippet. So here we have a list with the numbers -2, -1, 0, 1, and 2. And then here we have a list comprehension, which simply calculates the squares of those numbers. So now if I run this, then you can see that we get here this list containing 4, 1, 0, 1, and 4. And now let's do the same thing with a set comprehension. So therefore then we use the braces. And then here we say for x in list. And then we want to have x squared. So now if I run this, then you can see that the set actually only contains 0, 1, and 4. And that's because sets are a collection of unique values, i.e. there are no duplicates. Okay, so that's the example that I want to show. And then here for the nodes, I basically again have only this one node, which states that the if clause, for clause, nested set comprehension, and the if else statement work exactly in the same way as with a list comprehension. So again, I'm not going to show them with regards to sets. Okay, so with that now, we've covered all my notes for comprehensions. And with that now, we've covered here all those miscellaneous topics with respect to data structures. So we've reached the end of this video. And then in the next video, we're going to start to go over my notes for control flow. So thanks for watching, and hopefully I will see you in the next video.